Hello, everybody. Welcome back. Today, we're going to talk about mathematics, the phenomenology of mathematics and what they are at a deeper level. And we're going to trail off into talking about computation and kind of the computational universe as well, a little bit towards the end. And as usual, I'm going to aim to say something that is, you know, meaningful, new, and non-trivial, so that it's worth your time, that I'm not just repeating somebody's ideas. I'm actually, presenting something novel and interesting that hopefully will be illuminating. You may not agree with everything I say, and that's obviously totally fine, but hopefully you'll get at least one interesting thing, hopefully more. I put on some Aqua di Gio to get me in the right mood. I think I'm not getting commission or anything like that. It's just a very well constructed scent, as I've made in another Qualia of the day. Which reminds me, the Qualia of the day today, it's amino acids as subtle drugs, just as how David Pierce would describe them. Some people actually might get quite a subtle but significant mood boost if they start the day with, let's say, a protein shake, because protein shakes have a ton of amino acids, whether they're serotonin or dopamine precursors or other things that it might affect your sense of well-being in one form or another. Or some people find protein shakes a little bit too anxiogenic. They cause anxiety, so it really has to be tailored person to person. But you can do it in a much more focused way. Now, obviously, none of this is medical advice. If you're like extremely conservative and anti-modifying your state of mind in any way, well, yes, of course, maybe you could say I'm corrupting the youth by talking about subtle drugs, but I'm assuming you guys probably like have tried weed and alcohol and probably psychedelics and dissociatives. So this in grand scheme of things is like nothing. So but yeah, subtle drugs. I've got 5 amino acids. I might actually go deeper into some of them in the future, but just some that are interesting. Definite effects. So L-tyrosine is a precursor for dopamine and norepinephrine. And again, one of the nice things about amino acids as kind of like a way to alter your mind is that they tend to be like rather rate limited, in the sense that, like, if you don't take enough, almost kind of like nothing happens. If you take above a certain threshold, you overwhelm the metabolic pathways, and then you actually get kind of like a boost of those neurotransmitters. But then if you take more than that, it really doesn't do very much. It's kind of like going to be like a fairly subtle, very subtle difference. Anyway, L-tyrosine, like before trying, something heavy duty like methylphenidate or Adderall for ADHD or something like that, maybe give L-tyrosine a try. I know people for whom it works. I take it probably like twice a week on average, like half a gram. It's subtle, but I like it. It's kind of a net positive, at least in my case. L-lysine, it's very subtle, relaxing kind of a effect also. Glycine. I think glycine is probably more noticeable. And I do caution against taking glycine every day at high doses, let's say 5 grams, because some people report some like development of tolerance. And then like if they stop taking it, kind of they get insomnia. And it is worth telling that people who are going through benzodiazepine withdrawal and take glycine, it does help in the moment, but it seems to exacerbate the withdrawal. So like, then again, for the average person who takes it every once in a while, it's going to be a very, very safe thing. And I think, yeah, I mean, if you're having a panic attack, before taking a benzo, see if glycine does anything. And it might actually help quite significantly. You can go all the way to like 5 grams. That's fine. L-theanine, this is lifetime supply of L-theanine. Yeah, I mean, L-theanine in, green tea is going to be at like a dose of like, 10 milligrams, 20 milligrams or something like that. Is like a very minor component. But you can take it like up to a gram. And honestly, it's still fairly subtle at those levels. And at least in my experience, above a gram, it doesn't really change very much. You get to 2 grams and it's the same as 1 gram. So like there's really no point in taking larger doses. If you kind of like need some kind of like very quick reduction in anxiety, and again, I don't think you should do this, often. It's just like an option for something to do every once in a while. You could combine you could combine like glycine and lysine and L-theanine. And finally, I will definitely make a video more specifically about this, but this is agmatine. And agmatine is a very, very interesting substance because it seems to have, from the neuroacoustics perspective, a very general blunting effect, which back in the day we speculated it probably was kind of like a noise inducer. If you take a gram of agmatine and then you have like an orgasm, it's just not going to be that good. Actually, you will notice kind of the waves of pleasure get kind of diluted and blunted, and they just don't travel very well. But so is going to be the case with sadness. And so, I mean, just as I suggested, maybe try L-tyrosine before you try amphetamines for ADHD or something like that. Maybe give agmatine a try before taking SSRIs, because the phenomenology seems to be similar. And so like if agmatine doesn't do anything to you for your depression or the anxiety for which you might be taking it, SSRIs might also not do. Again, this is not medical advice or anything like that. It's just, I don't know, from one psychonaut to another. Here's some like relatively safe, suggestions. I don't want to be, construed in any other way. But yeah, subtle drugs. I think if we find a way to essentially tap into the opioid and dopamine system in a way that is like subtle, but like does not cause withdrawal or tolerance or a come down, that's going to change the world. So I think even though, obviously a lot of the things they talk about are like about extreme states of consciousness, like DMT or 5-MeO DMT or salvia and things like that. No, probably in terms of like everyday life, kind of like world changing, something that could substitute for coffee that is less anxiogenic and slightly more euphoric would just be a huge, huge, huge deal. So very worth investigating subtle drugs for that reason. All right, now on to the topic of the day. Look, mathematics is very confusing on many fronts. And I'm just going to, right off the bat say that Platonism doesn't really work. It might work if you revise it quite a bit. And instead, I'm going to be arguing for the general, explanation space where mathematics is actually about the study of patterns of qualia. And in fact, as is going to be clear down the line, you actually, when you are studying a particular pattern of qualia, you yourself are a much more complicated pattern of qualia. So actually, mathematics as an activity involves something much more interesting and complicated than just instantiating particular patterns that are isomorphic to the ones that you're studying, because the process of studying it itself requires a much more complicated object. And hopefully this will make sense as we go along. The thing is, again, because it's fairly complex, we do require quite a bit of background assumptions. So I'm going to give you a little bit of a background. You've heard quite a bit of these things in the past. If this is the first video that you see, you probably will be confused, but this is just to kind of like load it up into our global workspace, create the QRI way of seeing, as I sometimes call it, the high entropy alloy of concepts that clarifies a lot of things, the QRI perspective. So first of all, indirect realism. And I've talked a lot about these. If you don't know what I'm talking about, I recommend seeing welcoming Stephen Lehars to the QRI lineages in the QRI website, because he wonderfully explains how actually we experience a world simulation that is kind of like a diorama, and it has a peculiar geometry, and it's not actually Euclidean geometry, although it represents Euclidean geometry, and that's fascinating hint or foreshadowing of what I'm going to be talking in a second. But yeah, I mean, essentially, a lot of physicists, a lot of mathematicians, they might be bright in many ways, but sometimes you talk to them, and after a while, it becomes clear that actually they are direct realists, and they're very confused about, for example, like red. They might think that, well, red is just how the brain processes a particular frequency of light. It's just a representation, or it's just the processing of a particular frequency of light. They might say things like that, not realizing that, wait, actually, there is the qualia of red, which fundamentally can actually represent audio, or it can represent feelings. It doesn't need to represent frequencies of light. There's a dissociation there. So essentially, once you realize that we live in a internal world simulation, now there's this problem of the input qualia mapping, and that's different from person to person. And actually, I think like it's probably different also for people who are very mathematically talented. They have an input qualia mapping that is more, finely tuned towards like mathematical cognition. And actually, yeah, it's maybe quite a different way of existing. But yeah, indirect realism is important. Essentially, math happens. I mean, it might be aided with a sensory stimuli in terms of like seeing the patterns in a piece of sheet, in a sheet of paper, or in a video, or even with audio or something like that. But that is actually just like helping you select and stabilize states of your internal world simulation. But actually, the heavy computing is going on in the world simulation. I hope that makes sense. Second, the key conceptual distinction between a recipe and review of a state. So you might notice I have a slightly hyperbolic cup from I went to New Orleans a couple months ago. Yeah, I just bought it for that one reason. It's slightly hyperbolic. Meaning it has negative curvature. So recipe versus review. So a lot of confusion in meditation, and I think also in math, goes away once you realize that there is a distinction between the recipe for a particular state, which is like what are the steps that you need to take to get it to that state, versus what the state feels like. And so in the realm of meditation, for example, there's a lot of like strange recipes. They might say something like focus on your breath, or do this attentional move or something like that, and then you get like this sphere of light that appears. Now maybe you don't actually experience that sphere of light if that is the intention you go into the experience, but it happens as a kind of side effect of of these focusing effects. And so it's kind of like the result of the recipe would be the review, what the experience feels like. And so with mathematics, this is quite relevant because the mathematical state of consciousness, or the state of consciousness that lends itself to mathematical cognition, is something that you can review independently of what is it that you're doing. And in fact, doing the mathematics would actually be the recipe for the state of consciousness. So in a way, if you really want to kind of explore the mathematical cognition, quality of mind, the recipe, goes along the lines of doing a math PhD or something like that. It's a very long recipe, unfortunately. Okay, so the third one is symmetry theory of valence, and then the fourth is neural annealing. Symmetry theory of valence, essentially, essentially the theorized worldview. This is a leading hypothesis. It's not something to which we're married, but is the idea suggested by Mike in Principia Qualia that essentially the thing that determines the valence of a particular formalism, meaning the mathematical object that corresponds to a particular state of consciousness, is its symmetries. And this is important because it might actually explain to a large extent why mathematical states of consciousness can feel so good if you really grasp. A lot of people don't get it, but like finding a beautiful proof can actually be very euphoric. And I think there's like reasons beyond just kind of like, like the social reward of doing that. No. Actually, the mathematical state of consciousness that is able to grasp the proof itself is expressing new and novel symmetries that are themselves very euphoric, and they can be very energized, especially when the proof is surprising. And remember, energy is kind of like a scalar on the intensity of something. So like something that is very, very symmetrical and surprising becomes energized and therefore extra euphoric. So very elegant proofs can be very, very euphoric for that reason, independently of like social reward. That's my understanding. That neural annealing, yeah, I mean, essentially, a lot of like problem solving happens through modulating the what we call the temperature parameter, to the point that you get like essentially deconstruction of preconceptions. We call it entropic disintegration. And essentially, then there is energy sinks. Essentially, there are structures that can capture energy. And from a different point of view, you can see it as like structures that radiate energy until essentially they settle in shapes that are really, really good at essentially dissipating energy. So that will make sense, or it will make sense why I'm talking about these when we get to what is going on with mathematical cognition. And then I made a whole video about the difference between attention and awareness. I'm just going to very quickly summarize it, which is that, I mean, essentially, in the models that we're playing with, this relies on nonlinear wave computing. I know there's a lot of background, but like if you really want to grasp these, I think it pays off to get there. So attention versus awareness. There's many configurations of mind, and usually you can sort of segment it into components that are attention and components that are awareness. Now, attention has several properties. Essentially, attention binds features. So the moment you open your eyes, there's going to be a field of awareness that has a lot of kind of like very basic qualia, like colors and textures, stuff, as we call it. And then as things become salient, you fixate your attention in the various components of your field of awareness, and that kind of like coagulates the features into phenomenal objects. So stuff becomes things. And as you pay attention to the scene, it actually becomes populated with a lot of things, whereas at first it was just kind of this blob of awareness. Now, ultimately, I don't think there is a hard distinction between attention and awareness, and there's a way of thinking where like attention is actually kind of concentrated awareness. But ultimately, the best way I've been able to kind of like factorize this difference is that attention essentially is the oscillatory complement to the field of awareness. So, and this becomes very obvious when you are like in very concentrated states of consciousness. If you can focus all of your mind into one point, you will notice how it feels like the entire field of experience is sending kind of a wake of energy that concentrates in the point of awareness, point of attention, and from it reflects back into the rest of the field. And so they're co-dependent, they're co-arising. Attention and awareness co-arise. And there's these very strange phenomena too, where like you can kind of like widen the field of attention. So like if you're paying attention here to one point and then you start widening and widening and widening, you can cross a threshold where you're actually paying attention to half of your visual field, and the other half is kind of the corresponding field of awareness. But then you can kind of like start narrowing down the other side, and the very trippy and interesting thing that happens is that attention becomes awareness and vice versa. Meaning that really there are two sides of the same coin, and in some sense it's kind of like the field of awareness is a bunch of reflectors that are used to focus where energy travels, and attention is, generally speaking, kind of like a place in your experience with a very high page rank. And page rank is, this algorithm in graph theory, which essentially calculates the probability that you will find yourself in a particular node if you're walking at random in a directed graph. We've talked about that. So attention is kind of like the very high page rank nodes. But again, if you modify the structure of the network of your field of awareness, a lot of strange things happen. Like, for example, there might actually not be like a point where things are concentrated. Instead, maybe the things are concentrated along a cycle, like a circle, or they may be concentrating. They may not concentrate at all. Like for example, if the grid is completely symmetrical, awareness and attention are essentially the same thing. And so actually in that case, you will experience kind of a strobing of experience. You can have this on meditation. It might take you like 20, 30 minutes, depending on your meditative skill, but this is something you can explore, and I encourage you to explore. Essentially, this is very important because the mathematical objects that you interact with actually rely on interesting new patterns of attention. And you know, and the extent to which you can coordinate streams of attention and make them bind in different ways, it will enable you to actually explore mathematics of a higher complexity. And so yeah, I mean, in some sense, you know, like kind of like mathematical ability does, I think, intimately relate to the particular kinds of attentional fixed points that you're able to generate and the way you can interlace them and interweave them. And in fact, I think, like, you know, what kind of mathematics you tend to be drawn towards will depend on what kinds of patterns of attention and awareness your brain, your mind, and your conditioning is best suited for. Yeah, you know, we might even predict, if we have a good enough model here, that, you know, maybe actually some particular kinds of maths may be dysphoric for you because the particular attention and fixation points that you require to represent the information may actually cause dissonance in the process. So, you know, there might actually be an explanation why some people find mathematics not only boring, but actively unpleasant. And yeah, well, one other reason why that might happen is that if you're spending most of your time in the world of people as opposed to in the world of things, yeah, no, the you know, patterns of attention and awareness are very different. If you're a very much a people person, you kind of like aggregate things with a particular, you know, particular bundle. You separate the world into personalities, which have like particular binding patterns. And if they're asking you to reason about a triangle or a square, or it feels like that actually can kind of hurt your internal representations. It's like, no, that's not how I want to segment the world. It's kind of messing my segmentation process, my parsing of the world, and vice versa. Yeah, you know, segmenting the world into personalities by somebody who is like a, you know, true mathematician who lives in the mathematical world all the time can be unpleasant. So don't force empathy on a very aspy super mathematician, because that's kind of a bullying move from a certain point of view. Take note. Okay. I'm gonna now go on to say that the theory of mathematics, there's many ways of, you know, slicing and dicing these, but the theory of mathematics that I'm gonna kind of you know, I'm gonna talk about it within this context of fictionalism. Well, so first of all, I am a finitist. I mean, I think like infinities ultimately are an artifact of syntax that is consistent. I think the semantics of infinity are kind of illusory. I mean, we represent infinity with things such as like two mirrors that are parallel to each other. But those are symbols, you know, those are ways of thinking about infinity. And when it comes to that, you know, when somebody takes LSD and experiences like a mirror room and they say something like, well, I felt infinity. It's like, no, actually what happened is that you felt a particular hypersymmetrical configuration of your world simulation where certain boundaries disappeared and it felt boundless for that reason. It doesn't mean that it was infinite. Actually, there was a precise, finite amount of energy and information in your consciousness, but it had a boundless quality. And I think it's the same, when you're like thinking about infinities in mathematics, you kind of have like this internal representation that is boundless in particular ways. No, it's not infinite. And actually, I don't believe in realized infinities because, again, in my model of reality, actually, you know, reality is just a gigantic collection of experiences and the structures that connect them. So for there to be something truly infinite, it would have to be an infinite experience, which I don't think conceptually makes sense. I think it's incoherent. Every experience will be a finite amount of information and energy. So infinities are very deceptive, and I think they can be helpful for making your syntax consistent. They can be helpful in physics for syntactic reasons, but semantically, I think it's incoherent. So I'm a finitist. I mean, I think like we have to whatever true theory of mathematics will ultimately work out. I think it's going to be something that essentially doesn't have infinities, except in a syntactical sense. But then, even kind of like more so, I'm going to say that the theory is a fictionalism. That actually, even Platonism as a concept, it's a fiction. It's a fiction inside the mind. Even actually, labeling all of these things as mathematics is part of the fiction. So now you're going to be taking the red pill for mathematics. Yes, mathematics was a story, as it turns out. But how come mathematics is so powerful at explaining the universe? Well, because the thing that is actually real is patterns of qualia. And patterns of qualia are absolutely real. And there are invariants in those patterns. And yes, those invariants actually is what reality is made of. But it doesn't mean that, there is some kind of mind-independent, outside kind of time and space true mathematics or something like that. No, because the very concept of mathematics happens in the mind and is a way of binding a lot of constructs into one high-level concept that has predictive ability. But that's it. It's not actually real in a platonic sense. Am I saying that, mathematics is something like the Lord of the Rings or something like that? In some sense, yes. By that I mean that, like, if you really want to write a wonderful story about the Lord of the Rings, actually really buying into it, believing, oh my gosh, yes, elves are real, is something that allows you to bring to life and vivify and render with more detail. I mean, essentially, you're kind of giving a carrot to the mind. It's like, yes, this is real. I'm tapping into something. And that energizes it more, brings it to life. So really believing in the Lord of the Rings. Of course, this is just a psyop to distract you from the fact that I'm one of the characters in Lord of the Rings. But leaving that aside, no. Elves are not real, guys. Elves are not real, okay? They're not. But believing in elves and dwarves and hobbits is helpful if you want to write good fan fiction. Likewise, truly believing in sets and functions and graphs and hypergraphs and manifolds and vectors is very helpful to contribute to the broad superfiction of mathematics. Essentially, really buying into it helps. Now, I'm not like dismissing mathematics at all. I'm just saying that there's something stranger and trippier going on, which is actually you're manipulating the structure of your consciousness in such a way that you have particular representational content that essentially carries within it information about patterns of qualia. And that's actually what is going on. But part of the fiction, the recipe that you need to do that properly, requires you to have a strange psychotic relationship to the contents of your experience, where you think of it as tapping into some Platonic world. It's insane. I mean, it's insane. All mathematicians are insane. In fact, utterly psychotic, but in a very adaptive way. Which brings me to the nature of intelligence. I also have a video about this, but in this context, the way this works out is as follows. So essentially, remember that there are energy minima. So, okay, like why does a soap bubble converge into a sphere? Is because every non-spherical configuration has potential energy, which makes it wobble. And as it wobble, it radiates out its energy until all of its energy gets dissipated and it becomes a sphere. So naturally, in general, this is not always, but in general, symmetrical configurations tend to be local energy minima. And, I think your states of consciousness are actually states of physics, two sides of the same coin. And so you energize your state of consciousness, and then it will tend to settle into attentional constructs that will have inherent symmetries. Now, if you want to represent something like a group or something like a more complicated, set of symmetries interlaced with each other, you do need to energize it more. I mean, essentially, Erdos would say, okay, sure, like he couldn't think of some mathematics without taking methylphenidate. Well, I mean, obviously, aren't there like T-shirts that say like mathematicians are machines that turn coffee into theorems or something like that? I mean, here I'm getting caffeinated for you and for making this fun and actually being able to instantiate these thought forms, although in this case, obviously, I'm instantiating something a little bit more complex, which is not only mathematical thought forms, but also philosophical insights on top of them. But yeah, I mean, essentially, you do require thresholds of energy if you then want to crystallize them into particular constructs that have enough symmetries to represent the mathematics that you're trying to work with. I'm going to give you one very basic problem. You probably saw it in high school. Actually, you really should have seen it in high school. So you think about this for a minute or two, and then I'll give you the solution. But essentially, what you have to prove, very, very basic, what you have to prove is that any triangle, no matter its shape, can be inscribed in a circle. Or circumscribed. Essentially, you can make not a circle. You can make a perfect circle, poorly drawn. But you can always draw a circle that contains the nodes of the triangle, the corners of the triangle, as points in that circle. How do you know this is true? Is it true intuitively? To me, actually, the first time I heard this, it felt weird. It's like, really? But no, it's absolutely true. It's absolutely the case. So think about it and introspect on what you're doing when you're thinking about this. I mean, even better, if you've never solved that problem, if you don't know the solution to it, I would even suggest like to pause the video and try to solve it on your own. Again, it's just a very simple demonstration so that you see what I mean in a second. Okay, so, I mean, essentially, symmetries, relationships of equivalence are energy minima. So you're raising the energy parameter of your consciousness so that you can essentially play with the various constraints of the problem. And naturally, the symmetries of the problem become highlighted if you explore the space enough with enough sensory clarity. So that is one component of this. And equivalence, a lot of mathematical problems are about equivalences in one way or another. You could actually argue that all of them are about equivalences. Even inequalities can be cast in terms of equivalences, although that's a rabbit hole I'm not going to get into right now. But then recall that, yes, in our theory, actually, there are to a first approximation, there are two very big energy sinks. One is symmetries for purely physical reasons, as I just explained. And the second one is recognition. I mean, essentially things that you have seen before or things that you want to see can be set up as energy sinks. In some sense, I think ultimately all energy sinks and all local energy minima are in fact based on symmetry. It just so happens that there are parts of our brain that essentially their network topology is set up in such a way that patterns that have been instantiated before via something like Hebbian learning become energy sinks. Now, at a microphysical level, that also will have to do with symmetries. Essentially, will be kind of the equivalent of the spherical the spherical soap bubble. But from our point of view, it has a much more semantic interpretation. It's something like, well, okay, yes, I've seen these before. That's exactly the reason why when you take DMT, which is to a first approximation an energizer of your consciousness, and you can take it to a very, very high energy, the things that you see are going to be hybrids between recognition, things that you've seen before. You can barely feed it sometimes, but yeah, you will see, okay, like a clown, the gestures and so on. And then the second thing is symmetries, right? So the gesture is not only a gesture, but also it's full of crazy symmetries in its skin, and there's like radiating balls of light that are like in resonance, and they're actually symmetrifying and forming grid patterns and wallpaper symmetries, and all of that thing is also going on. Yeah, there are going to be hybrids between those two things. Exactly the same with mathematics. When you're trying to solve a theorem, you're trying to prove a theorem, you are setting up your mind in such a way that the thing that is desirable, the thing that becomes the local energy minima, are precisely the things that satisfy the constraints of the problem. Essentially, as you explore the various configurations, the various lines you could draw, how you could draw them, their equivalences, symmetries get highlighted, let's say parallel lines, or perfect orthogonal lines. Those get highlighted. Lines are of the same length. They also get highlighted. That's another kind of symmetry. But then also the things that solve your problem. And so in this sense, it's the same concept of intelligence that I was talking about, which is intelligence has like several components, and it's not how most people think about this. Because you're energizing this physical field, essentially, intelligence is all about, first of all, identifying a self-organizing principle that, if you instantiate it, will essentially, its energy minima will be pertinent to your problem. But then you also need to essentially make a mapping between the constraints of your problem and that particular self-organizing principle in such a way that, physics will solve the problem for you. This is the same thing I've talked about as the icing problem. You can essentially, figure out how to, constrain satisfaction for, scheduling, how to avoid like scheduling conflicts in a very large school or something like that with a lot of classes and a lot of people with different programs and so on. You can set that up as an icing problem and then do something like nonlinear optical computing annealing. And then actually, it's not that you're doing it manually. You're letting physics solve the problem for you by finding the local energy minima of that self-organizing principle. And so my understanding here is that, yeah, probably people have somewhat differently shaped parts of the brain with slightly different network topologies. Part of it is innate and part of it is based on training and early life. But my guess would be that somebody like John von Neumann probably had a few novel, regions of the brain or parts of the brain that were like shaped in a slightly different way that had different network topologies, such that he could recruit them as a part of a self-organizing principle that just happened to be very good for a wide range of mathematical problems. Of course, ultimately this is going to be testable, and if it's true, that might be the path towards, mathematical superintelligence is essentially giving you a wider diversity of possible network topologies such that you can recruit them for solving your problems. The other thing is another thing is that not only do symmetries get highlighted, also quasi-symmetries. So things that like ought to be symmetrical, but they're slightly not. So essentially, if two lines should be parallel, but they're like not exactly parallel, that's going to be highlighted and is going to be surprising. Or if there's like a missing piece, let's say there's like a cube, but actually one of the corners is missing, that also is going to be highlighted as essentially a dissonance, because as a symmetrical transformation via resonance is happening, that missing piece essentially is going to ultimately create like an out of phase interaction, which would be highlighted as an error. And so a lot of mathematical cognition happens also via identifying quasi-symmetries, or like the absence of symmetry where there should be one. Now, very quickly, I'm gonna, oh, excuse me, I'm gonna show you how to solve this problem. So, um, and there's like kind of like a lesson from this. So essentially, it's like, well, okay, how do you find the circle? How do you construct it? Well, here's the thing. It seems that if you want to actually draw a circle, it's gonna be the case, right? That like the circle is gonna have a center, right? And then part of it is that, you know, every point in the center to any point in the circle, its distance is the same, right? So you can actually transform this problem into the problem of identifying a point in the triangle or outside the triangle, depending on the shape of the triangle, such that it's equidistant to every one of the corners. And does that point exist? How do you know it exists? So, well, you can then reason in terms of symmetries. Well, if you have 2 points, what is the region of points that is equidistant to it? Well, you know, that's not hard. You essentially draw the line between the two, and you put up, you know, orthogonal line. Any point here is gonna make essentially an isosceles triangle. Okay, so with this insight, then what we can do is, okay, we take our triangle. All right, let's take the geometric region where all the points are equidistant. So any point in this line is going to be equidistant to both of these corners. Okay, how about we do the same for the another line? Oh my gosh, actually they intersect. What is special about this point? Well, we know that this point is equidistant to these two lines, to these two corners, because it's part of this line. But also because it's part of this other line, we know it has to be equidistant. You know, and the moment you realize this is happening, subjectively, at least in my case, but I'm sure, you know, we should study mathematical phenomenology, but there's some kind of highlighting that happens where you realize, oh my goodness, this is equal to this. And this is equal to this. So all of a sudden the three become kind of highlighted because they're in a state of resonance via equivalence. And as a consequence, they're a local energy minima. That representation, that gestalt of those three lines in resonance is highlighted. It's a local energy minima. And as a consequence, this line and this line are also the same. Right? So, well, they will also belong to this line. So not only did you just find out, you know, that actually that's going to be the center of your circle, you also found out that these three lines actually converge into the same point. So that is one example. I mean, I invite you to, like, as you solve other, you know, geometric problems, or, you know, in mathematics more generally, notice how whenever something gets highlighted, something is like, wait, actually, maybe this is significant for the proof. Or, oh my gosh, this is a piece of insight necessary for, it's going to be either because you're recognizing a feature that you think is relevant, that you set up your mind, you know, you preconditioned your mind for that to be an energy sink, or is itself something that has an inherent symmetry, like that gestalt, that it had like these essentially three lines of the same length, which becomes a symmetrical gestalt in one sense. And essentially that's going to be happening all over the place. So again, I think, like, yeah, if you're very mathematically oriented, essentially you have kind of this bias towards essentially amplifying those energy, you know, those energy things. They become very, very big highlight. Essentially, it's kind of, you know, kind of in a Beautiful Mind, or I forget, like, what other movies. Sometimes they kind of like, oh, all these mathematical equations, and this gets highlighted, and like they get connected. Yeah, it's actually kind of like that. In that equivalences all of a sudden actually become highlighted and interconnected. And ultimately, yeah, the proof is going to be something along the lines of this is equal to this, which is equal to this, which is equal to this. As in a consequence, the last two things are actually equal to each other. Okay, so let's get on to this is, I guess, like, yeah, the last third of the conversation, which is uh, well, this gives rise to essentially an intentional network of dependencies. So actually, when you're reasoning about a mathematical object, the reasoning itself as a thought form will be a network of interrelated equivalences. And sometimes they're transitive and sometimes not. And actually, I think we can learn a lot from pseudo proofs. And I think that's actually where essentially it's an artifact of resonance where you're identifying things that are equivalent in the network, but you're not being careful enough to realize the type of equivalence that they share. So one example is, okay, prove that these two lengths are the same. Well, you could use this length as a side of a rectangle here, and then this length as the other side of the rectangle. And you could say, well, this one is equal to the rectangle, but you're not encoding properly. Equal in what sense? Well, it's equal on the horizontal dimension. And this length is equal to the rectangle, but you're not encoding it properly. You don't realize it's only equal in terms of the vertical direction. And so you may make the false equivalence that actually these two lengths are the same via transitivity. So that would be an example where like there's an artifact. You're actually getting a resonant gestalt, but that's not actually capturing the information that you want because you didn't set it up properly. You didn't actually realize that there were two dimensions. And I think like a lot of like pseudo proofs are like that. Essentially are, failures of equivalence where you confuse one type of equivalence for another, and there's transitivity of equivalence that is actually not there. It is in your model, in your mental model, which is in some sense slightly psychotic, but yeah, it's actually not there mathematically. If you go deeper into these, I mean, like mathematics, again, like these patterns of attention and awareness, they tend to be constructed within the dualistic self-other divide. Reasoning about triangles, you can, and usually that means that there's going to be a larger field of awareness, essentially paying attention to a smaller, region of attention. But in meditation, it's not quite like that. But there's still a lot of like very interesting, math-inspired meditation you can do. I'm soon actually going to be talking to somebody who does a lot of like sacred geometry for meditation. I really agree with his metaphysics or his interpretations, but I do agree that the meditations can be really powerful. I mean, one example, a very basic example is like you find kind of like you start fixating your attention at the top of your head, and then you raise where you're paying attention to until you feel there is kind of like a ball of light, kind of like a sun. Well, yeah, I actually do think there's like a particular region above your head where if you pay attention to it, you experience a more intense reflection between the awareness and the attention. Why? It's very similar to an ellipse. In an ellipse, essentially you have two focal points, right? And every point in the ellipse, if you add up the distances to both focal points, that quantity is the same, right? So it's kind of like that. There are regions in your field of awareness where if you point your attention, it will form a kind of eigenmode, essentially a nonlinear resonance structure, where essentially the waves of attention will kind of like bounce off of the boundaries of your experience and come back at the same time. And as a consequence, that's going to be a more euphoric state of consciousness, again, because of symmetry theory of valence. So in some sense, the fact that, okay, these sacred geometrical structures can have like very interesting valence effects. It's kind of like if you were to give somebody a coffee without them knowing that it has like psychoactive effects, they might say like, I don't know why I liked it so much, but it's probably magical. Or if Sasha Shulgin found somebody actually in Brazil who used to give retreats, and he would say they were drug free and they had like a magical sacrament, then people will say like, yeah, we take the magical sacrament in the ceremony, and all of a sudden it feels like I'm feeling the same love that I felt when the day of my marriage, and all of that is revived. This truly must be magical. Well, it turns out there was MDMA there was MDMA in the sacrament. Um, well, I think like sacred geometry is kind of like that. I mean, like they say, okay, do these particular patterns of attention and awareness, and notice how that feels like it's purifying your soul. And the truth is that yes, something is getting purified, something is feeling a lot better, especially if you do it very often and rigorously, and you concentrate your attention. But I think it's a valence effect. And now most people will generally use that as kind of to sell you their metaphysics. It's like, yes, of course, this indicates that my theory of the lines of the network of the energy flow of the universe is correct because the sacred points or something like that. Well, yeah, that's I think that's kind of a sleight of hand. I mean, it's the same thing. It's not magic. It's essentially something that can make sense with valence structuralism. Now, the reason I bring this up is that the difference between that kind of state, like the sacred geometrical state, using it for valence effects directly, or spiritual effects directly, as opposed to mathematics, is that in mathematics, the window of attention tends to be smaller. And as a consequence, there is more of a self-other divide. Whereas in sacred geometry meditation, usually you're actually finding the points that are like exactly at the center of the symmetry, that divide your field of awareness in 2 or in 3 or in other ways, that make it balanced. And if you do that, then as a consequence, the self-other divide melts away. So it's actually non-dual in phenomenology. Very, very strange. So actually, you can, I think, like, do that a lot, and then like you just slightly break the symmetry, and then all of a sudden you're in a mathematical cognition state of consciousness. Or what also happens is if you play a lot with mathematical cognition and then you just set it up right, you can melt into it and have a mystical experience. So yeah, I mean, in some sense, mathematics is kind of a gateway to the sacred, well, to strong valence effects, as I would describe them. This takes me to the one of the final points, which is that I mean, essentially, if you want to represent a particular mathematical object, let's say a set, you will need at minimum a graph to make sense of it, because as you're paying attention to the set, I mean, think about this also in terms of the zero time arrow for those who know what I'm talking about. It doesn't matter if you don't know about it. But essentially, if you're reasoning about a set, actually you're going to be connecting dots in terms of equivalences. And that's going to be actually a kind of like jittering around. You're going to form gestalts within the set. That is something that you need at least a graph to kind of like make sense of. So in other words, the actual information encoded in your experience of a set is not just a set. It's at least a graph. And if you want to reason about graphs, you're looking at a graph and thinking about it mathematically, and you're finding equivalences or patterns, symmetries and structures. You're at the very least actually using a hypergraph to reason about it in terms of the actual data structure of the information flow in your consciousness. Which actually takes us to this very, very interesting point, which is that it may not actually be possible to explicitly represent the true mathematical object that corresponds to your consciousness. It actually may be kind of a blind spot. It's just a tad too complex because it cannot represent itself. It would be sort of like, oh, can you express a set with sets? The answer is no. You need something a little bit more complex than that. Can you represent the mathematical object that encodes consciousness within it? Maybe not. It doesn't mean that it's epistemologically impossible to find out. Again, I am a very radical epistemological optimist. I very much think that a lot of people give up way too soon. But I do think it's not going to be the case of, okay, let's just find the proper state of consciousness that represent the mathematics of your consciousness. It's going to be actually in a kind of like indirect way, where you do a lot of experiments, a lot of phenomenology, a lot of neuroscience research, and they all give you clues. They can tell, okay, from this experiment and the fact that you were able to instantiate this mathematical object, it means that this is the lower bound of the symmetries contained in your experience, the latent symmetries. So at least it has this kind of symmetry group, at least. But then from this neuroscience angle, we might bound it in a different way and say like, well, at least it has these, set theoretic equivalence, or this category, or something like that. And then in another way, via physics, you might be able to bound it differently and say, well, okay, these are all of the forces in physics. And if you assume physicalism, not everybody will agree with that, but if you assume physicalism, that this bounds it in this other way. It kind of have more than this. And then you can narrow it down and say like, okay, this is the one mathematical object that has all of the properties necessary. So we probably are that. And then you can develop experiments specifically to test that it might make, novel and daring, precise predictions. And I think, something like that is going to be the path to like reverse engineering the mathematics of consciousness, not revelation. It's not going to be like a direct thing. And it's going to be weird. It's going to be weird, I think. Okay, so I'm just going to say a little bit about computing because this is going to be the topic of another video, much more expansive. But essentially, computing is kind of like the sequel of mathematics from the point of view of fictionalism. Computing theory in computationalism is kind of a mathematics part 2 with the arrow of time or something like that, where it's not only about mathematical patterns anymore, it's about mathematical patterns that change over time. I don't think computing is like much more sophisticated than that. I mean, like, all of these proofs that exist about, for example, the Turing equivalence between computational mechanisms. Like, okay, you can use cellular automata like the game of life to instantiate any program because, it's Turing equivalent. It's equivalent to a Turing machine. Or you can use Carol the robot and, these introduction to computer science kind of entities. That is reasoning about how patterns change over time and the invariances that they can generate and the equivalences between them. Some people think that mathematics, like pure mathematics without ever considering consciousness, is enough to explain the universe and everything. And some people say like, well, no, maybe not mathematics, but computing might be. I'm here to say, computing is just mathematics plus time. And it's also part of the same fiction. And when you're reasoning about computing, it's kind of the same. I mean, you're instantiating these states of consciousness that, well, now it's not only, instantiating structures that are of a higher complexity to be able to look at those structures. It's actually something kind of stranger too, which is like you're instantiating paths of the pseudo-time arrow, essentially timelines, and you're reasoning about timelines and their equivalences. It's kind of like this braided structure. But also, I mean, you're doing that and you think you're reasoning about something that is like almost kind of a metaphysically, yes, this is computing itself. But no, actually what you're doing is you're modifying your state of consciousness in order to highlight particular patterns of qualia. And you cannot bootstrap consciousness out of that. Yeah, I mean, I think that's a huge red herring. Doesn't mean that, computation isn't powerful, because it absolutely is enormously powerful. But I think that ultimately, when it comes down to it, a theory of consciousness will not come out of just pure computing. You should read my response to Scott Alexander is called on Rhythms of the Brain, Janus, Local Field Potentials and Electromagnetic Theories of Consciousness. Is a Qualia computing article. Yeah, I mean, essentially I go into why trying to reduce everything to a cellular automata is actually a red herring. And the answer is there's a lot of things in physics that I think really don't fit that. I mean, you can overfit that metaphysics and create a cellular automata with a very complicated rule set and say like, okay, these one might explain fundamental physics. But I think usually always will involve a sleight of hand, where what is going on is that you're taking the holism of reality and you're pushing it to the rule set and then pretending that it's now computational. but not really. I mean, actually, there was continuity and there was actually holism involved. So instead, I think like to understand reality, you actually need something much more radical, something like zero ontology. Like I discussed in Why There Is Something Rather Than Nothing, the video. And then on top of that, I think like, yeah, these concepts of like, well, actually, you can reconstruct all of reality in terms of patterns of qualia and qualia values that cancel each other out. And is not that reality is made of these symmetry groups, is not that reality is made of these programs. It's something much crazier, which is that these patterns of qualia have that particular structure that can give rise to something that behaves like the mathematics that we study. But the deep truth is the patterns of qualia, and everything else is a fiction on top of it. I hope that helped. I think that's it. I will just very briefly conclude with ultimately I think that exotic states of consciousness are not just scrambled neurons or something like that. I actually think that will enable us to have like new philosophical cognition as well as new mathematical cognition that essentially, as I've written about, the hyperbolic geometry of DMT experiences, when you can actually instantiate a truly three-dimensional hyperbolic structure with interesting topologies in your experiential field, that allows you to actually reason about it in a completely new way, is better in some ways than just reasoning about it abstractly. And also it makes it matter, right? Actually, because if those states of consciousness have valence characteristics, they have the ways they vibrate, have like positive or negative valence, actually they matter, right? Like which DMT state you arrive at matters because it depends on whether you suffer or you experience a heavenly world. And I think the key to understand whether it's one or the other actually will come down to the mathematics of that state. The symmetries or asymmetries present in it, the waveforms, the envelopes of the waves. And so all of that is deeply, deeply mathematical. It makes it matter. It's not like, well, hyperbolic, manifolds are kind of stamp collecting. It's like, well, if you have some kind of like obsession with like systematizing it, like maybe it matters to you, but no, all of a sudden it actually matters for everybody. Because if we develop the technologies to access these states of consciousness reliably, we want to dial into those that A, feel good and are healthy and coherent with the rest of your life, and B, have non-trivial computational power. And actually this is where I think like the true intelligence explosion will arise, which is the states of consciousness that we instantiate because we understand better the mathematics of consciousness will allow us to then have more computational power for qualia computing, which in turn will allow us to predict the existence of further states of consciousness with further computational powers and so on. That I think is the true kind of computing revolution. I mean, the computing revolution obviously matters a lot, but this is kind of on another level. Is the computing of consciousness, qualia computing revolution. And with that, thank you very much. As always, very enjoyable. I hope you enjoyed the sacred geometrical patterns and the melting into the field of awareness and attention, becoming one with the rest of your experience. I'll see you another time, another topic. Infinite bliss. Take care, everybody.